Hello everyone. Last time we finished the chapter Z transform. Now let us start the next chapter, that is state space analysis and realization structures. So before starting with this realization structures, we'll see what is meant by digital filter, what is a FIR filter and what is IIR filter. Okay, so I will define digital filters. So digital filters are frequency selective network which allow to pass desired band of frequencies and reject the frequency outside this band. Okay, so this is a definition of usually any filter. Filter is allowed to pass the specific band of frequency. If it is a low pass filter, it is allowed to pass the low band of frequency and reject the high band of frequency, that is reject the frequency outside the cutoff frequency, isn't it? Okay, so digital filters will be defined like this. It's a frequency selective network which are allowed to pass the desired band of frequency and reject the frequency outside this branch. Now what is the use of filter in communication? So usually filters are used in communication for two purposes. To extract the useful information, we use the filters. Okay, so अनवांटेड इंफॉर्मेशन हम लोगों को निकालना है एंड यूजफुल इंफॉर्मेशन हम लोगों को एक्सट्रैक्ट करना है, तो विल यूज दिस फिल्टर्स. सेकंड थिंग इज टू रिमूव द अनवांटेड नॉइस. ओके, ड्यूरिंग ट्रांसमिशंस नॉइस विल बी सिग्नल्स पिक अप द नॉइस एंड देन at the receiver side, if you want to remove the unwanted noise, we can use these filters. Okay, digital filters are classified into two types. Finite impulse response filter, which is we call as a FIR filter. FIR, finite impulse response filter. Second one will be infinite impulse response filter. IIR, infinite impulse response filter. So IIR filter. The filters are classified into two types, FIR and IIR. Let us see first of all FIR filter. Okay, so usually what is the importance of impulse response? So impulse response will describe the basic behavior of filter or any system. Okay, so suppose it is a low pass filter. Low pass filter, how does it behave? What is its nature? So its nature is allowed to pass low frequency and reject the high frequency. So this basic nature is mathematically represented by its impulse response. Okay, so that is we call it the basic nature of filter or basic behavior of filter. So basic nature of filter or basic behavior of filter is mathematically represented by its impulse response. Okay, and if the impulse response of the system, so if you see low pass filter having the different impulse response, high pass having the different impulse response, because nature of behavior of both will be different, exactly opposite, बराबर है. सो दोनों का इम्पल्स रिस्पॉन्स आप लोगों को मैथमेटिकली अलग अलग एक्सप्रेशंस में रिप्रेजेंट किया रहेगा. ओके, तो एवरी फिल्टर हैज इट्स यूनिक impulse response. Okay, so if the length of the impulse response is finite, then such filters are called as finite impulse response filter. Okay, so let us say that for example this one. Okay, यहाँ पे h of n जो है it will be represented by 1 and minus half. So there are two samples in impulse response and there are only two samples, because of that its length is 2. Okay, and therefore this is we called as a finite impulse response filter. Its length is finite and therefore it is we call the finite impulse response filter. This impulse response is finite length. Okay, and therefore it is we call the FIR filter. Okay, then let us, if we take the z transform of this h of n, we'll get the h of z, which is equal to 1 minus half z raised to minus 1. Okay, but y of z is nothing but y of z, h of z is nothing but y of z upon x of z. So from this we can obtain the difference equation of this filter. Okay, whose behavior will be represented by this h of n. तो इसको y of z मिला, इसका अगर हम लोग इनवर्स z ट्रांसफॉर्म लेंगे अभी, सो ये x of z इसको मल्टीप्लाई कर दिया ऐसा, and if we take the inverse z transform, we are getting the y of n is equal to x of n minus half. This is what it is, x of n minus 1. Okay, so this is we call the difference equation. Okay, so this is a FIR filter whose impulse response will be this one and difference equations will be this one. So this filter is either represented by this impulse response or it is represented by this difference equation. Okay, isn't it like this? So if you observe this output equations, what does this output equation shows that the output, present output of the system, present output of the filter will depends upon present input, this is present input, and past input only. Okay, isn't it? So this is one of the properties of FIR filter. The FIR filter का जो output है, present output, it depends upon input only. It does not depends upon previous output वगैरह. Present output depends upon present input and previous input, like this. Okay. Now let us see here. This is a block diagram of this FR filter. इसका block diagram निकाल देते तो ऐसा है. X of n है. Okay, when x of n will be passed through a unit delay, this is we call the unit delay element will represented by d. So this will provide a delay of 1 to the incoming signal. So जो signal x of n आ रहा है उसको x से delay करेगा, तो आगे जो signal जाएगा that is x of n minus 1. Okay, so x of n minus 1. So here you are getting x of n minus 1. Here you have the x of n. Then you have to obtain y of n by using this difference equation. So y of n is equal to this x of n. Okay, and x of n को multiplier क्या है, minus half, तो minus half multiplier will be represented by this circle. This is circle, not square. Okay, multiplier will be represented by the circle. Circle से represent करते हैं और उसमें वैल्यू उसका multiplier का वैल्यू. Okay, so y of n is equal to x of n, okay, minus half into x of n minus 1. So इधर से जो सिग्नल आ रहा है x of n minus 1 आ रहा है, उसको minus half से multiply होगा, वो इधर आएगा, इधर से x of n as it is आएगा, दोनों को additions करेंगे तो you are getting y of n. So this is a block diagram of FIR filter having this impulse response, isn't it? So FIR filter present output depends upon present input and past input only. FIR filter does not contain feedback. So if you see here, some part of output does not return back to the input. ये output है, output का कुछ भी part इधर input side में नहीं जा रहा है. Okay, so it does not contain the feedback. Feedback किसमें रहता है कि some part of output will return back to input. But in FIR filter, it is does not contain feedback. FIR filters are non-recursive filter. अभी recursive और non-recursive. So अगर present output depends upon previous output, it is we call a recursive system. Present output depends upon previous output, then the system is recursive. Okay, isn't it? So यहाँ पे present output does not depends upon previous output and therefore system is non-recursive. ये non-recursive system है. Okay, present output depends upon past input only, not past output. Okay, now second one will be IR filter, FIR filter. If the length of the impulse response is infinite, then such filters are called as the IR filter. For example, h of n is equal to half raised to n u of n. Okay, अभी u of n has value 1 for n equal to n greater than equal to 0. मतलब u of n का value 1 है from n equal to 0 to infinity. And therefore, this if we put here n equal to 0, we are getting 1. If we put here n equal to 1, you are getting half. N equal to 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, 1 by 64 and so on. Okay, ऐसा continuous रहेगा up to the n equal to infinity. मतलब impulse response जो है इसका कितना है, infinite. Length कितना है इसका, infinite. So length of this impulse response is infinite and therefore such type of filter we call as the infinite impulse response filter. Isn't it? Infinite impulse response filter. Okay, so filters are classified like this in these two broad categories. Now if you take the Z transform, again जैसा हम लोग ने FIR का किया वैसा analysis का करते हैं. We'll find out Z transform. Why you take the Z transform? Because we often difference equation obtain करना है हम लोगों को. डिफरेंस इक्वेशन ऑब्टेन किया कि हम लोग पता चलेगा कि ये इसमें फीडबैक है क्या नहीं है, इसमें ये पता चलेगा कि ये रिकर्सिव है क्या नॉन रिकर्सिव है. देन डिफरेंस इक्वेशंस मिल गया कि उस पर से हम लोग उसका ब्लॉक डायग्राम भी निकाल सकते हैं, इजंट इट. उसके लिए हम लोग ये डिफरेंस इक्वेशन ऑब्टेन कर रहे हैं. तो एच ऑफ एन से डिफरेंस इक्वेशन कैसे ऑब्टेन करते हैं, तो एच ऑफ जेड ऑब्टेन करते हैं, एच ऑफ जेड से वाई ऑफ जेड ऑब्टेन करते हैं एंड देन इनवर्स लेते हैं उसका. तो एच ऑफ एन से एच ऑफ जेड ऑब्टेन किया बाय टेकिंग इज जेड ट्रांसफॉर्म. ना हाफ रेस टू एन यू ऑफ एन का जेड ट्रांसफॉर्म क्या रहेगा, ये इन दी फॉर्म ऑफ ए रेस टू एन यू ऑफ एन है. तो तो a रेस टू n u ऑफ n का z ट्रांसफॉर्म क्या है, z अपॉन z माइनस a, देयरफॉर इसका z ट्रांसफॉर्म विल बी z अपॉन z माइनस हाफ. ओके, अभी इसको नेगेटिव पावर सीरीज ऑफ z में कन्वर्ट कर लिया, तो 1 अपॉन 1 माइनस हाफ z रेस टू माइनस 1, डिवाइड न्यूमरेटर डिनोमिनेटर बाय z, ऐसा किया तो ये ऐसा कन्वर्ट हो गया, isn't it? Then h of z is y of z upon x of z, क्रॉस मल्टीप्लीकेशंस किया, and then we'll take the inverse z transform. We are getting y of n minus half y of n minus 1 is equal to x of n, and this is a difference equations. Output of the system y of n is equal to x of n plus half y of n minus 1, half y of n minus 1. And if you see this difference equation now, present output will depends upon present input and previous output. Okay, so in FIR filter, present output depends upon present input as well as past output. Okay, and since the present output depends upon past output or previous output, system is called as recursive filter, a recursive system. Okay, and therefore IR filters are called as the recursive filter. Okay, and every recursive filter will contain the feedback. हर एक रिकर्सिव सिस्टम जो रहेगा उसमें क्या रहता है, फीडबैक रहता है. अभी ये डिफरेंस इक्वेशन से ब्लॉक डायग्राम कैसा निकालते हैं हम लोग. ओके, तो दिस इज एडर, दिस इज अ साइन ऑफ एडर, प्लस साइन दिखाया हुआ है मतलब ये एडर, एंड एडर को ये इनपुट दिया हुआ है, ये एरो इधर आ रहा है तो ये दो इनपुट दिया हुआ है, एंड ये एरो बाहर जा रहा है मतलब ये एडर का आउटपुट है. तो एडर को दो इनपुट दिया है, वन इनपुट विल बी एक्स ऑफ एन, ओके, and another input will be this one, so that will obtain the output of the adder will be, हम लोग को adder का आउटपुट चाहिए y of n, तो ये जो adder का आउटपुट है वो y of n है, और यहाँ से उसको हम लोग ऑब्जर्व कर रहे हैं. ओके, सो दिस इज अ y of n आउटपुट. सो यहाँ पे y of n है मतलब आपका दिस y of n इज गिवन टू यूनिट डिले, दिस विल प्रोवाइड इट, यूनिट डिले एलिमेंट विल प्रोवाइड डिले ऑफ 1 टू द इनकमिंग सिग्नल, तो यहाँ पे सिग्नल आएगा y of n minus 1. ओके, तो इधर y of n minus 1 हो गया, y of n minus 1 को हाफ से मल्टीप्लाई होगा, तो यहाँ पे जो सिग्नल आएगा एडर को इनपुट करके वो कौन सा आएगा, माइनस हाफ इंटू y of n minus 1. तो y of n इज इक्वल टू दिस y of n इज इक्वल टू x of n, ओके, प्लस हाफ ऑफ y of n minus 1 प्लस है, सो दिस इज प्लस है, सो दिस विल बी ऑल्सो प्लस. ओके, प्लस हाफ ऑफ y of n minus 1. So x of n plus half y of n minus 1 is y of n. तो if you see now, some part of output है, ये output है, some part of output will be returned back to the input side. Okay, मतलब इसमें feedback है, ऐसा closed loop है. Okay, and so this system contain feedback. Okay, every recursive system will contain the feedback. So this is we call the IR filters. So exam में usually compare FIR filter with IR filter आता है हमेशा. तो कंपेयर जब करना है आप लोग FIR विद IR फिल्टर, तो पहले उसका डेफिनेशन देना है, लेंथ इज फाइनाइट, लेंथ इज इनफाइनाइट. देन सेकेंड यूज दैट दी इन FIR फिल्टर प्रेजेंट आउटपुट डिपेंड्स ऑन प्रेजेंट इनपुट एंड पास इनपुट ओनली. हाउएवर IR फिल्टर कंटेन दी IR filter present output depends upon present input as well as past output. FIR filter are non-recursive, IR filter are recursive. FIR filter does not contain feedback, IR filter contain feedback. And then you have to give the example, एक इम्पल्स रिस्पॉन्स दिखा के उसका ब्लॉक डायग्राम ड्रॉ करने का डिफरेंस इक्वेशंस करके, ऐसा आप लोग कंपैरिजन दे सकते हैं 5-6 पॉइंट करके उसका. ओके, वेरी वेरी इंपॉर्टेंट, एग्जाम में जनरली पूछते हैं. थैंक यू.